Hi friends, welcome you all to Think Max. We are in class 11 Max, chapter 11, three-dimensional geometry. Okay. So in this session, we are going to learn the basic concepts involved in three-dimensional geometry. It is a very simple chapter. Already in 10th standard, you have learned coordinate geometry. In that, you have learned about two dimensions, that is X and Y. I think you all remember this x-axis and y-axis. So these are the divisions in x coordinate and these are the divisions in y coordinate. If I mark a point P here, so this coordinate will be here. The distance from x is 2 and the distance from y is 2. So 2 comma 2. So this point is marked like this. And this is a two-dimensional system. Examples are square, rectangle. They are all examples of two-dimensional system. In this chapter, we are going to learn three-dimensional geometry. Okay. So there are only three topics: rectangular coordinate system, point in a space, and distance formula. If we learn all these things, this chapter will be very easy. Okay, very simple chapter. Just learn the basics and the formulas, then you will be able to solve all the problems. Okay, so shall we get into the problems? Yes. So three-dimensional geometry, you will have three types of dimensions. So what are they? So one is length. So this is not the length and this is the length. So this is length and this is width or breadth. And this is width or breadth and the last one is the height. Okay. So in two-dimensional, we have learnt length and the width, x-axis and y-axis. In three-dimensional, we will be having the height. So x, y and z. So these are the three coordinates in three-dimensional geometry. So examples of this shape are, this is a cube and it is a cuboid, cone, and this is the shape of a sphere and this is the shape of a cylinder and this is the shape of pyramid. So these are all examples of three-dimensional system. Okay. So in this you can find length. So this is the shape of the cuboid. So this is called cuboid and this is cube and this is cuboid. Cuboid has, this is length, it is in x-axis and this is the width, we note it as y-axis and the height is z. So these are the three dimensions of the cuboid. In the same way, we will be having three dimensions for cone and this is sphere and this is cone and this is cylinder and this is pyramid. So these are the examples of three-dimensional system. We will be having length, width and height. So in variables we note it as x, y, z. So if we take a point in space, this point will be in space. So x and y are two-dimensional. So this is z, this is the height, it will be in space. So the point P will have three coordinates. If we note a point in space, the point P will have three coordinates. So this is the basic for the three-dimensional geometry. Clear? So shall we go to next page? Yes. Rectangular coordinate system. What do you mean by rectangular coordinate system? So here you have learned two-dimensional geometry with x-axis and y-axis. So this is called x-axis and this is y-axis. So if you have the height, it is denoted by z-axis. So this is the height, it is denoted by z-axis. These three lines will be mutually perpendicular. Okay, as it is the height, it can not be shown in the plain figure. It is the height. This y and z will be perpendicular. Y and x will be perpendicular. X and z will be perpendicular. So these three lines are mutually perpendicular. Such a system is called rectangular Cartesian and coordinate system. Okay, if the three lines are mutually perpendicular, then it is called rectangular coordinate system. We can note it as x perpendicular to y, x perpendicular to z, y perpendicular to z. That means they are perpendicular to each other. Then it is a rectangular coordinate system. Clear? So moving on to the next topic, coordinates of a point in space. Okay, so this is the three dimensions x, y, and z. Okay, we took a point P in space. So this is the point. This point is nothing but perpendicular from x. So this is the perpendicular from x. So this distance will give you the value of x, and the distance in green will give the value of y, and the distance in blue will give the value of z. So P is denoted by x, y, z. P of x, y, z. So this is a point in space. Its position is given by x, y, z. For they are perpendicular distance from y, z plane. So x is the perpendicular distance from y, z plane. So this is the plane y, z. Okay, and this is perpendicular to this y, z plane. This plane. Okay. Now, if you take the coordinate y, this is perpendicular to the x, z plane. So, this is perpendicular to x, z plane. And if you take the value z, this z is perpendicular to this x, y plane. Okay. So, these are the values. And the origin. This O is denoted as origin. This origin has the coordinates 0, 0, 0. Okay. So these are the coordinates of a point in space, and this is the coordinate of the origin. Clear, children? Shall we move on to the next one? Yes. Coordinate axis and coordinate planes in three-dimensional space. We learned the point, how to mark the point P in space. Now we will learn the axis and the planes. So these three planes intersect along the line. There are three planes, this square shape, parallelogram shape, rectangle shape. They are all planes. They all intersect along the lines x, O x dash, y o y dash, and z o z dash. So they are called, this x o x dash is called the x axis, y o y dash is called the y axis, z o z dash is called the z axis. So this is the axis, and we call the plane x o y. So this plane is called xy plane, XOY. So this plane is called XOY plane, and YOZ. Where is YOZ? Okay. So this plane is called YZ plane, and ZX. Z is here, X is here. This ZX is called ZX plane. So there are three coordinate planes. So how many coordinate planes? There are three coordinate planes, and this is called the origin of the coordinate system. These three coordinate planes divide the space into 8 octants. So the name of the octants are X, O, Y, Z. So you can find X, O, Y, Z. So they divide into 3 octants, 8 octants. This one of the octant is X, O, Y, Z. These three lines. In the same way, we find 8 octants X, O, Y, Z, X dash O, Y, Z, X dash O, Y dash Z, X, O, Y dash Z, X, O, Y, Z dash, X dash O, Y, Z dash, X dash O, y dash z and x o y dash z dash. So they are all denoted by Roman numbers 1, 2, 3, 4, 5, 6, 7, 8. So 8 octants are denoted by the Roman numbers 1, 2, 3, 4, 5, 6, 7, 8. So in this, you have to learn the name of the octants in the same order. Okay, so this octant is shown here. The name should be learnt in the same order so that you can find out the octant numbers. So X, O, Y, Z means first octant. X dash O, Y, Z means second octant. In the same way, you will get the octant numbers. So this is one important question in this chapter. So you have to learn the name of the octant so you will be able to find out the octant numbers. Clear? So shall we move on to the next one? Yes, when a point lies on coordinates, that is when it lies on x-axis, its value will be x comma 0 comma 0. So if the point is on x-axis, this is x-axis, then it has the coordinates x comma 0 comma 0. If the point is on y-axis, it has the coordinates 0 y 0. If it is in z-axis, its coordinate is 0 comma 0 comma 0. And if it is in the plane xy plane, then the coordinates will have the values for x, y, not for z. If it is in yz plane, it has the coordinate values for y and z. So it will be 0 comma y comma z. Now if the point is in xz plane, then it has the coordinate x, 0, z. Clear? So these are the point which lies on coordinates. So moving to next topic. So the next one is octant system. So we already learned there are 8 octants in 3D space. Let us learn the signs of those 3 octants. Okay. So there is a point. If there is a point P in space, its coordinates will be x, y, z. If the point P is in space, it will take the x coordinate as x, y coordinate value is small y, and z coordinate is the distance z. So it takes the value x, y, z. So the sign of the coordinates of your point determine the octant in which the point lies. Suppose if the point are all positive. So all the points are all positive. Then it lies in x, y, z plane and its octant is 1. First octant. Okay. So second octant means its signs will be minus, plus, minus. X coordinate will be negative and y coordinate and z coordinate will be positive because if you check this name, it is x dash y is it. Okay, if you have a dash on the variable, then it takes the sign negative. So if you remember this, that's why I told in the previous page, if you learn the order of the name of the plane, then this signs will be very easier. So if you have a dash on the coordinates, its sign will be negative. So the third octant will be on x dash O, y dash Z. So the sign will be negative, negative, positive. That is x coordinate is negative, y coordinate is negative and Z coordinate is positive. So if it is on fourth octant, it will be in the plane x, O, y dash Z. Then it will be positive, negative, positive. If it is on fifth octant, it will be x, O, y, z dash plane. Then it will be positive, positive, negative. If it is on sixth octant, its plane is in x dash O, y, z dash. So its sign is minus, plus, minus. If it is on seventh octant, its plane will be on x dash O, y dash, z dash. Then all are negative. Okay, all the three coordinates are negative. If it is on eighth quadrant, then its plane will be x, O, y dash, z. Okay. Then its sign will be plus, minus, minus. So this is an important one. You have to learn this table using this name of the plug. So if you learn this table, exercise 11.1 will be very, very simple. Clear? So this is one of the important table. Next, we will see the formulas related to it. So what are the formulas? The first formula is distance between 2 points. So already we learned in coordinate geometry, that is two-dimensional geometry, we learned the distance between A and B. So it is x1, y1, x2, y2 in two dimension. In three dimensional, we have three coordinates, x1, y1, z1, and that is a point B with x2, y2, z2. So if it is so, the distance AB is given by square root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. The same formula as in coordinate geometry which you have studied in 10th standard. Extra one thing is you have to add z2 minus z1 whole square for three-dimensional geometry. So this is the first formula. Next one is if the 3 points are collinear. Okay, if the 3 points are collinear, then we have to show that AB plus BC is equal to AC. That is, if you have a line A, B, C. Find the distance between AB and then find the distance between BC. Then find the distance between A and C. If you add AB and BC, it should be equal to AC. Then it is collinear. We say these points are collinear. The distance between AB plus distance between BC is equal to distance between AC. So this is the condition for collinearity. Clear? So this is the next formula we should learn. Next is isosceles triangle. So what do you mean by isosceles triangle? Yes, you all know that two sides are equal. Okay, A, B, C. So in isosceles, two sides will be equal in length. Two angles will be equal and two sides will be equal. If you want to prove that these 3 points lie in an isosceles triangle, then you should prove that two sides are equal in length. AB should be equal to AC. This is the condition for isosceles triangle. Okay, next is right triangle. So you all know that right triangle has 90 degree. So let me name it. If it is A, B, C, this is 90. So this is the hypotenuse side. So what is the condition for right triangle? Hypotenuse square equal to sum of the square of the two adjacent sides. So hypotenuse square means AC square. So AC square should be equal to AB square plus BC square, which is called Pythagoras theorem. So you have to find out the distance and take square. Square means this root gets cancelled. So find AB square, find BC square, add it, it should be equal to AC square. If it is so, if this condition holds, then these points lie in right angle triangle. Clear? So we have to learn all these four formulas. And the next one is parallelogram. So parallelogram, what we know? We know that opposite sides are equal and parallel. So this AB will be equal to DC and AD will be equal to BC. So find all the distance, find all the four sides distance and check whether AB is equal to DC and AD is equal to BC. If it is so, then these 4 points lie in a parallelogram. Okay. So if you learn all these formulas, then this chapter is very simple. Just you have to learn the octant table and the distance formula and the condition for collinearity, isosceles triangle, right triangle and parallelogram. So this chapter will be very simple. Okay. In the next video, we will discuss the example problems. Okay. Thank you.